All right, let's talk about two types of confidence intervals, and this is going to be very similar to your exam where I'm going to give you the formulas, but just because I give you the formulas doesn't mean that you shouldn't study. You have to review what these symbols mean. So in a sample of 50 LB boys, it was found 38 of them plan to attend college. Construct a 95% confidence interval for the true percentage of LB boys who want to attend college. Interpret in a sentence. So P hat, that means a sample proportion. So our sample, we didn't ask all the LB boys, we just asked 50, and we had 38 out of 50. And is that, what percent is that? 0.76. All right, so 0.76 is our sample proportion. We're gonna plug in a 0.76 here, here, and here. Our N is our sample size. Not all the boys at LB, but those that we sampled. 50. The Z star, and I'll give you this information, for 95% is 1.96, if you forgot about that. Now it's just time to plug in these values. So we're gonna have 0.76 plus or minus 1.96 square root 0.76, 1 minus 0.76 divided by N. You want to be careful when you do this in your calculator that you follow order of operations. So the square root of 0.76 times 0.24, you guys get how I'm just saving myself some typing. 1 minus 0.76 is 0.24, and then all of that divided by 50, and then close your parentheses. So you get 0.06. So we have 0.76 plus or minus 1.96 times 0.06. So order of operations, I'm going to multiply that, or 1.96, sorry, times 0.06. And that is 0.1176. And now we're going to remember, I like to subtract first. And I'm just going to round this to 0.64, and then 0.76 plus the 0.1176 rounds up to 0.88. So that is your, this right here is your answer, and it leave myself much room to write my sentence. I'll write it over here. So we are 95% confident the true proportion, don't say mean, we're talking about proportions, of LB boys going to college is between, and then if you want to write these as percentages, you can, or you can write them as decimals, 64% to 88%. Okay, let's do the same thing with a sample mean. So it is known men's heights are normally distributed and the true standard deviation is 3 inches. Suppose you found the height of 7 random men at a basketball game and found the following heights measured in inches. Calculate a 90% confidence interval. So we need to plug in X bar. That's the sample mean. Okay, so on a calculator, I went ahead and found the mean. I just added all these up and divided by 7. So our mean is 69.6 inches. The Z, that's for a 90%. Again, I'll give you a chart that shows all of these on your exam. Standard deviations given, right? So what I'm doing is I'm just plugging in all these numbers that are on the equation. N is your sample size, and there's 7 men that were measured, so we use a 7. So now you just basically plug this in. 69.6 plus or minus Z is 1.65. Standard deviation divided by square root of N. So 1.65 times the square root of 3 divided by, oh no, I don't want the square root there. Sorry, 1.65 times, and we want this in parentheses, 3 divided by the square root of 7. 1.87, I'll just say 1.9. So 69.6 plus or minus 1.9. Again, I like to do the subtraction first. 69.6 minus 1.9. And 69.6 plus 1.9. So we only measured 7 people at this basketball game, but we're trying to come up with the true proportion, or the true, mean average height. So we are 90% confident the true mean, remember this means true mean height of men is between 67.7 and 71.5, and make sure you label inches or else it's kind of meaningless. All right, hypothesis test. Read these over and try to pick which hypothesis test we're talking about. If you kind of skim through this, it sounds like two proportions, 35 out of 57, 26 out of 70. So that would be a two proportion Z test. Do you think golfers have a better score on their first round or their second round? So we're going to compare each individual golfer's first score to their second score. So instead of a two sample t-test, this is the most missed question here, it's actually a matched pair, and we're going to practice one of those in a little bit. And then our professional basketball players significantly taller than 75 inches, a random sample of 30, and we are given the true standard deviation. So we would have one set of data comparing it to 75 inches. It's definitely not proportions. It's not, you're not comparing a before and after or like a first round and a second round, and it's not going to be two samples. So all you have left to decide between is a Z test and a T test. They give you the true standard deviation, you know that's a Z test.